Music has countless styles, but what if we could teach a computer to recognize them? In this project, we've built a music genre classification system that combines MATLAB, Python, and ESP32. Using MATLAB, we extract advanced audio features like spectral centroid, flux, and MFCCs to build a detailed dataset. Then with Python, we train and evaluate machine learning models to identify the genre of any song. Finally, the predicted result is sent to an ESP32 microcontroller, enabling real-time display and interaction. From digital signal processing to AI and IoT, this project brings together the best of all three worlds to make machines truly listen to music. Let's dive right in.
I'm going to explain how the MATLAB code analyzes the song, detects its genre, and then sends the results over to our ESP32 microcontroller. So let's do it step by step. The first step is configuration, that is where we configure the test song. So in our code, we have configured it to Don't Stop Me Now. We also specify the IP address and port of our ESP32, which will later receive the predicted genre. The next step is loading the datasheet. That is, the script loads a datasheet. In this code, the datasheet's name is genrefeatures.csv. This file contains pre-extracted music features as well as many songs along with their genres. The next step is training the model. So we train our model with the K nearest neighbors model, which is the KNN model for short. It learns how to group similar songs together. In our code, we have taken K equals to 5, meaning that it looks at the 5 closest matches while making the predictions. The next step is analyzing the test song. So this is where we actually analyze our song. So we load a test song and the extracted advanced audio features. So in our code, the audio features that we have extracted are spectral centroid, rule of point, zero crossing rate, MFCCs, and various others which help us to predict or categorize our song mathematically. Next is the actual step where we predict our genre of the music. So once the features are extracted, we feed them into our trained KNN model as we have seen previously, and then MATLAB will predict the genre of a given test song. So over here the genre can be pop, rock, jazz according to our code. Then the genre will be displayed on our console. The next step is to send this result that we have obtained over to our ESP32 microcontroller. So the script sends this predicted genre over Wi-Fi using a TCP connection to the ESP32. So our ESP32 will now show the results on the LCD and the LED will glow to show the predicted genre. The last step is error handling. So here we have wrapped it up with an error handling block, that is we have added a try-catch block which will handle the error during analysis or communication.
So this MATLAB script is designed to create an enhanced music genre dataset using advanced audio analysis features. It begins by setting up the environment and specifying the main music folder, in this case called music library. Next, the script initializes an audio feature extractor which is configured to capture a wide range of characteristics from each audio file such as spectral centroid, spread, roll-off, flatness, flux, entropy, skewness, kurtosis, and even MFCCs. Then it automatically scans through all the subfolders inside the music library, each subfolder representing a different genre. For every song within each genre, the script reads the audio file, resamples it to a consistent rate of 44.1 kHz, converts stereo tracks to mono if necessary, and then extracts the selected features. It averages those features across the entire track to represent it as a single feature vector and stores them along with their corresponding genre labels. Once all the genres and files are processed, the script defines clear variable names for each feature and organizes everything into a structured table. Finally, it saves this table as a CSV file, creating a clean, ready-to-use dataset for machine learning, classification, or further analysis. The result is a complete enhanced dataset that combines multiple spectral and MFCC features, a robust foundation for building accurate genre classification models.
This is a demonstration of our SNS project. Firstly, we can see that our setup consists of multiple electrical components. You can see that we have a button here, our ESP32, our LCD and a potentiometer to control the brightness of the display as displayed here. Now, firstly we will click to start the entire operation. You can see that it is connected to my mobile hotspot. Once it is connected, it will show its IP address. Then it will be waiting for our client responses. I have to take this IP address and update it into my code, as you can see here. Once this is done, I will run the code. When I run this code, it will start the prediction analysis and give me an output. Here it has predicted the genre as metal. Now you can see that my LCD has also been updated and it shows that the predicted genre of the song is now metal.